Hi, everyone, and welcome. I'm Chandni Chopra, VP People and Culture at TestMe AI, and I'll be your host for this session at TestMe Conference. It's great to have you all with us today. And before we get started, just a small ask as you listen in, share in your key takeaways on LinkedIn or Twitter, tag us and use hashtag TestMeConference so others in the community can follow the conversations too. And if you've got any questions during the session, feel free to drop them in the Q&A box and we'll take up the questions towards the end. Okay, so let's dive into the session. We hear a lot about the promise of ML-driven test intelligence, faster feedback, smarter test selection, and anomaly detection that can catch things traditional automations may miss. But taking that promise from an idea to something that actually works in production is where things get interesting. Today, Talk takes us inside one of the largest financial institutions in the United States, a highly regulated environment, massive transaction volumes, zero tolerance for silent failures, and deadlines that simply don't move. So the real question is what actually works, what doesn't, and why? We're joined by Tanvi Mittal, software quality lead at US Bancorp, who brings over 15 years of enterprise experience in software quality and testing. Tanvi has been driving AI augmented testing strategies at US Bank, architecting large-scale automation frameworks, and integrating ML-driven test intelligence into production pipelines. She's also an IEEE senior member with peer-reviewed research on ethical AI governance for multi-agent systems. She's a creator of two open source tools, LogMiner QA and Prompt Armor, and the founder of her next tech community supporting early career women in technology. So please join me in welcoming Tanvi Mittal as she takes us through Beyond the Hype, ML-driven test intelligence at scale, what works, what fails, and why it matters. Tanvi, over to you.
Thank you, Chandni, for a very detailed uh, description about my work. Let me share my screen. Is it visible? Um, okay. So let me just make it bigger. Good morning, good evening, everyone. I want to start with something I think most of us are working in AI testing are beginning to realize nowadays that generating tests is becoming cheap and cheaper. And we can ask a model for test cases, API scenarios, jerkin, edge cases, even automated code, and that's useful. But I don't think that's the problem, that's the hard problem anymore. The hard problem is what should we test next? When the system is changing continuously, when model behavior is probabilistic, and when prompts and retrieval change underneath us, how do we know where the next meaningful test should come from? And that's what I mean today by test intelligence. Not more test generation, but better testing decisions. And the reason I started thinking about this differently was actually a very small experiment I can did. So I want to show here a very simple example. In the right, if you see in one context, I asked GitHub Copilot to fetch an account, a user's account balance by user ID. It gave me the parameterized query you see on the left. It's a very good secure pattern. Then in essentially the same code base, I introduced a little more surrounding complexity and asked it to add a date filter. And suddenly it fell back to string concatenation. Now, what is interesting here is the second answer was not wrong. The interesting part was, and that was not a knowledge problem even. It was an activation problem. The model has the capability, but the surrounding context change whether that capability actually showed up in the output or not. And And I also tested this with 11 case Copilot battery using the safer rubric. And I was trying to answer a different question, like how stable is a known capability when context change. And that question has become much more important to me than simply asking whether a model can do something once. So, how many of you have seen an AI assistant produce the right pattern in one place, then completely forgetting it 20 lines later? I think this happens with all of us. So, that behavior is what breaks several assumptions that our test automation has quietly dependent for years. And we usually summarize this as a non-deterministic behavior of AI, but I think that's too shallow right now. So these are the at least four things which I consider as main criteria where the AI is breaking our traditional assumptions. The first one is output is unstable. Fine, we know that. But the oracle is also unstable. Sometimes there isn't one exact expected sentence or exact answer. The change surface is bigger. Behavior might change because we have changed the model, or the system prompt is being changed, or the retrieve context is changed, or there is more than one tool call. And then coverage becomes uncomfortable, because what exactly does 80% coverage mean when context combinations are effectively unbounded? So for me, the shift is this: we are moving from verifying output to measuring behavior. And that sounds subtle, but what changes is how you design the entire testing strategy. Take an example. For a traditional API, I may assert status code is 200 and a known schema. That's what we have been doing so far. But for an AI workflow, I may also need to ask what the right tool selection is. Was the retrieved evidence used? Did the model preserve a policy constraint? And did it do that consistently across context variations? And when I say test intelligence, I'm not talking about asking an LLM, give me 20 test cases. That's generation, useful, but it's different. Test intelligence is the layer that continuously asks three questions. You can see the three questions on the screen. The first one is, what should we test next? How strongly can we assert the expected behavior? And how much do we trust the thing doing the evaluation? Those three questions are where most of the difficult engineering work is. The model writing the test is often the easiest model in the whole pipeline. And this gets more painful once you move beyond a demo and stop operating at scale. And I think we all have experimented this, like everything works good in demo, but once you move or ship to production, the things start breaking, or we see the actual behavior. And when I said scale, I'm not talking only about thousands of test cases. The scale shows up in four different ways, and I have listed down them here. The variance, like we can have different prompts, we can have different contexts, different tool calls, and user journeys. Churn, model, there is a difference in model version, prompt is changing, retrieval changes. Then privacy. Your best test data may exist in production, but you cannot just throw production logs into an external model. And the last one is auditability. Especially in regulated systems, someone eventually asks a very boring but very important question: why did this test become a release gate? And how you need a real answer. So execution is not really the bottleneck anymore. The bottleneck is deciding which signals matter and which assertions deserve the trust. And that led me towards a closed loop way of thinking about testing. So this can be this model here can be the center of the talk today, because uh, there are two entry points here. On one side, we know there is a known risk. They may be secure coding, they may be hallucination, tool misuse, authorization, compliance. Those becomes the offline evaluation. On the other side, there is a production signal that tells me something I did not already know. In production signals, we have strange user journeys, a rare sequence, a new failure pattern, a behavior that simply never appeared in our authored regression suits we have tested so far. And both signals should enter the same pipeline. We need to observe them, we need to prioritize them, reconstruct enough context to reproduce the behavior, define the assertions, then validate them. Then either CI or human makes the decision. And most importantly, whatever we learn needs to flow back. If a production incident teaches me something once, my test system learns nothing from it, then I haven't really closed the loop. So I can give you and explain you with this an example. Imagine a customer journey where login succeeds, a downstream service retries twice, and then a transaction enters a state where we never represented in pre-production. The intelligent response is not just to fix the incident. It is to ask, should that observed journey now become part of our permanent evaluation? So, and we'll take this model in the further slides and try to explain and create a mental model for how the test intelligence work. And I like LLMs. I also use them, but I don't want an opaque model making an uninspectable release risk decision. Um, so I have derived the framework kind of. My priority is uh, it should be a novelty, it should be unique, it should be exposure. What is the exposure of the issue? How much is the impact, and how much I can reproduce it? So if this is genuinely unusual, how often could users hit it? If it fails, how bad is the consequences, and can I reproduce it reliably enough to act on it? So the model can help estimate some of those goals, signals, but the decision should remain inspectable. So if the answer to why this classified as high risk is because GPT or any model said so, that's not a risk model. It's just a number. I'll again give you an example. A rare formatting variation may vary very high novelty and almost zero impact. A slightly unusual authentication sequence may be less novel but very high impact. So, and those two should not be treated the same way. And because no signal mechanism catches every failure mode, I like to have a layered evaluation strategy, which is we are going to see next. So in any framework, we can divide it into three layers. The first layer is the manual review, where we doing the reviews and testing by human, and human in the loop is doing the spot checking. Then layer 2 is automated CI/CD evaluation, and the layer 3 is production monitoring. So this layer is similar to the Swiss cheese idea, and it's applied to AI evaluation. So manual review is catching nuisance, but that's not scalable. Automated CI/CD evals scale much better, but they inherit the weakness of their assertion and judges. And production monitoring shows us the reality, but by definition, we are seeing that signal much later in the process. So I want these blind spots to be different, and that's the important part. So if every layer is ultimately asking the same LLM the same question, then we haven't built three layers. We are actually building dependency three times. And this is where I want to move from framework into something concrete. So this is an open source tool I have worked upon. This is a LogMiner QA is the one implementation of part of this closed loop. So it is not my definition of test intelligence. I built it around a practical problem. Production was showing us behavior our test suite did not know about. So we have a lot of data and we have a lot of logs in a production, which from actual user journeys and actual user behavior, which we hardly get to see in our lower environments. So the problem was that production logs are noisy, they are very sensitive, and unusual doesn't automatically mean important. So first, what I have tried to do is I am sanitizing the data before the downstream intelligence touches it. Second, identifying the behavior that looks unusual. Third, prioritizing the useful patterns, and then turn that selected ones into the candidate test cases. And because we are talking about the regulated environment, then privacy and on-prem are not negotiable decisions. So I didn't start with let's build an ML testing tool. I started with how do we stop learning the same production lessons twice. And let me tell you, the first challenge was actually was not ML, it was the privacy. So we'll see how uh, this tool or this layers work around. So and I took the privacy changes as the first priority because I feel really strong about it. A lot of AI systems are sanitizes data after they have already passed it through the intelligence part of the pipeline, and that's very uncomfortable in regulated environments. So my approach is to redact first. So if you see here in the flow, there are raw telemetry entering into the system. I use Regex plus structured patterns and domain validators and spaCy NAR where its sensitive values are replaced with stable representations, so we can preserve the correlation without preserving the actual values. And only after that, I create features or embeddings and run anomaly analysis. So suppose the same account identifier is appearing in 6 events across one customer journey, and I don't necessarily need to capture or save the real account number, but I do need to know that all these 6 events belong to the same account number, right? So that's why I have used a stable token reduction matters. Uh, Once the data is safe enough to analyze, the next step is thinking anomaly detection means defect detection. The next one is the um, and this is where the another assumption I had to unlearn. A rare event may be a defect, or it may be a very important customer. It can be month in processing. It can be a new feature rollout. It can be a perfectly legitimate edge case. So I have used isolation forest or embedding distance, where it makes sense for the journey level sequence anomalies. Um, and but none of the anomaly detection are declaring any of the unusual thing as a defect. They are the candidate for our test generation. So risk plus reproducibility is deciding whether the candidate deserves a testing attention or not. So I'll tell you an example here. Imagine 99% of payment journeys follow A, B, C, D. One journey goes A, B, retry B, C, and manual review is done on D. That's very interesting. But before turning it into a regression test, I still need to understand whether it's representing a failure, it's an accepted recovery path, or it's simply a rare legitimate workflow. So this is where the anomaly detection is helping me to further drill down the candidates for the test automation out of my production logs. And then the interesting part is Uh, this is probably the part I think AI testing discussions underestimate the most. LLMs are very good at producing convincing looking tests. They have very nice names, nice jerkin, nice given when then. Then sometimes the test proves almost nothing. Yes, we all have seen that. The difficult part is the oracle to walk the pipeline and reduce it to the minimum scenarios we need. We need to ask what invariant should have held, and then only we need to generate the testing candidates. And after generation, we need to validate the syntax and semantics, replay it, duplicate it, and then only promote it into regression. So let's say suppose production shows repeated failed logins followed by an unsuccessful session, followed by a successful session. A weak generated test might say then the user should be logged in successfully. Okay, that test almost nothing. The meaningful invariant might be after number of failed attempts, the expected security control must trigger and an auditable security event must be recorded. Now the test has a reason to exist. A synthetically valid test is not test coverage, and the same Oracle problem appears when we use an LLM to just another LLM. So I hope these three sequential slides about anomaly detection, uh, uh, generating the stable tokens, and then generating the test cases from production log is making sense right now. And LLM as a judge is extremely useful, but the word judge gives it a level of authority it hasn't necessarily earned. So, LLM as a judge is still a model, and before we allow it to get a release, I definitely want a human labeled cases from our own problem space. Then I measure where the judge is disagreeing, not just the average disagreement. I am caring about the slices, like does it fail more often on security? Is it giving ambiguous responses? Is the it is having long context cases? Is it covering edge cases or edge conditions? And then I define the confidence threshold and importantly, a human fallback zone. So an evaluated LLM judge is just another untested dependency according to me. So if my judge agrees with the human 95% of the time, that sounds great. But suppose most of the time, 5% disagreement is concentrated in the exact safety cases I'm using it to gate. Then that 95% is a terrible number. The distribution of disagreement matters more than the headline accuracy. So Uh, when I put all of this together, there were three assumptions I realized I had been carrying into AI testing from the traditional automation, and I want to discuss a little bit more about them. First one is capability. Capability does not equally means reliability. Seeing a model perform correctly once proves capability, it doesn't prove stable activation. Second is anomaly. So anomaly detection is not equal to defects. And the third one is generated test does not equal coverage. A beautiful automated test with a weak description or 30 test cases without covering all the use cases is still weak coverage. And I would probably add a fourth now, calling something a judge does not make it objective. So if you wanted to take one piece of this back into your own team next week, I wouldn't tell you to build everything I just showed you. Instead of what you can work on is you can start with a much smaller piece. You can start with one flow, pick one AI assisted flow where getting the decision wrong actually matters. Uh, Instrument 8, capture enough lineage that when behavior is changing, you can tell whether the model is changed or the prompt has changed or the context has changed or the toolpath has changed. Then close the loop, find one production derived behavior, sanitize it, again replay it, and define the invariancy, like what difference did you find? And then promote it into your eval suite. So that's one loop, and definitely keep a human in this band. So if there is any strange tendency in AI projects is to automate ambiguous decisions simply because we now have a model capable of producing a score. Uncertainty is not a defect in my opinion, and sometimes it is most honest state the system can return. And I would say, like, there are a lot of different frameworks or eval frameworks available in online and open source. So don't just start by installing 4 eval framework. Start by making sure your test system can learn one more new thing from production. And I think we are getting on time. So I would just say that AI testing at scale is not about generating more and more test cases. It is about learning what deserves to be tested before the system changes again. So, if you want to remember one thing, just remember you need to observe, prioritize, validate, learn, and then feedback that again. Um, And yeah, that's all I wanted to show you, like how you can use the production logs or anomaly detection and generate the test cases and find the gaps. That is one way of um, using ML in the larger scale. And also, I have put a logminer QA repo on the GitHub. It's an open source if you like to explore it and check more about it. And definitely, you can reach out to me on LinkedIn. And if you like the logminer QA, just give some stars on the GitHub repo. Thank you.
Thanks, Tanvi. What a great session it was. We'll also take some questions we have. Not too many for today. We might be running out of time, but I'll take one or two questions if we can have them on the stage, please. So, how do you prevent log driven test generation from creating redundant, overlapping, jerkin test cases as production log volume scales? Tanvi, would you like to take that up?
Yeah, so I think the question is the log generation can produce a lot many unwanted test cases, right? So the thing is, we definitely need to review it manually, and then we need to uh, compare it with what the existing test cases we have, and then filter it out. That could be the one way, and then we can have another LLM as an agent, which is comparing the test cases what we have from the existing repo, and then filtering those out.
Great, thanks, Tanvi. We'll take another one. What governance model works best for agentic QA?
Um, I have worked on a framework which is called SafeR, which is safety, reliability, and there's two more terms. So yeah, I can share more that about, and it's on my GitHub repo. So yeah.
Fantastic. What a great session. And let's thank you, everybody, for attending this insightful session. And so let's keep the conversation going beyond this session as well. As Tanvi said, you can connect with her on LinkedIn, but do share your takeaways on LinkedIn and Twitter. Tag us and use hashtag #TextMeUConference so others can join the conversations too. And a small reminder, the sessions will also be available on YouTube channel, so you can come back to them later, revisit the discussion, and share them with your teams and peers. And before we move on to our next session, do some take time to explore our partner booths, meet the teams, exchange ideas. We also have some fun contests lined up, so make sure you check those out as well. And thank you once again. Happy testing. Enjoy the rest of your conference.
Thank you for having me. Thanks, everyone.